we may have met briefly at the DSET conference. Sarah, it's nice to see you. I don't know that we've met before. I'm Randy. And Jay McPhillips, I know we saw your face earlier. It's a pleasure meeting you. So we are a very small group. My name is Randy Kochever. It's my pleasure to introduce Joanna Ohlmeyer. Joanna works with me at EDC and is actually the author of the lesson that we're going to be talking about today. So I'm thrilled to have her joining us from Peru. Thank you so much, Joanna. And so Joanna has a much more intimate understanding of the lesson than I do, and so as specific questions come up and suggestions come up, Joanna, I'd welcome you to chime in and answer those questions, and also it will help us. This is a lesson that we're in the middle of developing. Joanna just brought it into the most recent version of our framework last week. And so we're still working out a lot of kinks, so you're seeing something brand new. Just by show of hands, Sherry and Sarah and Jay McPhillips, were you here for Aaron Barter's webinar a few weeks ago, back in January?
Unfortunately not.
Okay, that's great. It tells me how much time I can spend on background. So I'm just going to spend a second here just giving you a little bit of background on the Oceans of Data Institute and the work that we've been doing at EDC. So this lesson that I've been referring to is called Zoom In Mobility. So we're going to be talking about some work that we've been doing, getting students working with some urban mobility data. I'll talk a little bit more about that later. As for myself, by training, I'm a marine biologist. I've been involved with, I initially came to Monterey, back in the early 90s to work at the Monterey Bay Aquarium Research Institute, and then I went to Monterey Bay Aquarium, and then I spent several years at Stanford University at the Hopkins Marine Station. And so a lot of the work that I've been involved with over the years was either studying the physiology of deep sea animals, or later on working on animal tagging and tracking studies, both of which are very, very data intensive enterprises. So I got a lot of hands-on training in terms of working with data, but I have never been formally trained either as a data scientist or as an educator. So, so many of the things that you all are expert in are things that I am still just learning. When we think about the marine sciences, it hasn't been that long ago that one of the main tools that was being used was direct observation. I love this image that my colleague Cheryl Peach sent me years ago. But in the modern day world of marine science and science in general, so much of what we know through the data that are collected either by remote sensors, or through genetic analyses, or radio telescopes, or in the case of the Tagging of Pacific Predators program, through tags that are put on the animals themselves, and they move through the ocean and take samples for us. So I think one of the questions is when we move from this world of sort of direct empirical observation to a world where we're understanding the world around us through lots of data. It gives rise to this idea of big data, and so in our work, we've tried to kind of get away from that big data term because it has a lot of connotations that aren't necessarily accurate. So we coined this phrase of clip data. So we focus on data that are complex, which means that it's not just a single variable, that there are multiple variables that are all interrelated. The data sets that we work with in education are large, which is to say that there's more data than you need to answer any one single question. So there's part of what we're teaching is sort of learning how to select the subset of the data that are relevant to the question at hand. we tend to work with data in interactive ways, and so that includes using the tools that have been created by our colleagues at the Concord Consortium. We'll be talking today about CODAP. We're also doing some development using Sage Modeler, which, if you haven't seen it, is really cool. And then also talking about using Lara, which is a lesson authoring tool. Whoops. And I don't know. Oh, yay. The other thing is that we often work with professionally collected data as opposed to student-derived data. And we can talk more about that in just a minute, why we do that and why we think that's important. And so, you know, so the challenge that we always face, though, is that data, when you're talking about data, even if you're working with relatively manageable sizes of data, it can very quickly become overwhelming. So there's this cartoon from the New Yorker, and if you can't make out what it says, "I'll pause a moment for you so you can let this information sink in." So some of the transitions that we need to facilitate as educators when we're working with these complex, large, interactive, professionally collected data sets is in a more traditional setting where students are collecting their own data and then working with it, is that there is this really experiential grasp of the data. The student has an intimate understanding of the data because they collected it themselves. But when we're working with these large data sets, oftentimes the only way that you can get access to that information is through examining the metadata. You know, where student collected data is oftentimes just, you know, dozens of data points. In these large data sets, we're often working with megabytes or terabytes of data. And finally, you know, with a simple data set, it's oftentimes possible to just take a piece of graphing paper and plot points and draw lines. But when we're working with these much larger data sets, you know, it typically needs a computer to do that work. And oftentimes the kinds of visualization and analysis tools that we use are very sophisticated, and it becomes an effort in and of itself just learning how to interpret a visualization or an analysis. So the way that we've taken that on is sort of this three-prong approach. And this is specifically related to our work in building data literacy in K-16 classrooms. So we've been working towards building a research-based learning progression where we really understand something about how data literacy is built from, say, you know, the time a student is, you know, kindergarten, first, second grade, you know, through grade school into high school, and then ultimately into their undergraduate experience. So far, the youngest students that we've worked with hands-on are middle school, but we have a couple of NSF proposals now that push that down into the late grade school and early grade school ages. So another piece of this work then is developing and testing tools and curriculum to help facilitate that learning, and that's some of what we'll be talking about today with this unit that I'm going to be showing. And then the final thing that we try to do is to bring people together, so much as Concord Consortium did such a great job bringing this group of people together for the DSET work and all of the follow-on work that has come. You know, in the Oceans of Data Institute, we've also tried to bring people together from diverse backgrounds so that we can learn more about sort of what data science is all about, how this field is changing, and how we can prepare people for success in it. And so as part of that effort, there are some initiatives that we've undertaken over the years. And this is all material that you can find on our website, but where we've brought together people with really diverse backgrounds, everything from agriculture to law enforcement to you know, from the marine sciences to treating cancer, and but all these people work with big data, and so we've created some occupational profiles, both of people who are professional data scientists, as well as people who are at that middle skills level and work more at the technician level. And then we did some work with IBM talking about, really in general, what data literacy means. And one of the things that came out of that work was this consensus definition of what we mean when we say data literacy. And so as we build programs, as we build curriculum, this is sort of that point north, that we're always thinking about is how are the skills that we're teaching lining us up to achieve this data literacy as we defined it here. So the ODI portfolio has consisted of a number of different projects. One of the first things we did was a 3-year study that kind of looked at what are the barriers to using professionally collected data in the classroom. That was followed by our Ocean Tracks project, which took some of the principles that were defined in that visualizing oceans of data work, finding an interesting data set, and then building curriculum materials around it to see if the things we thought were true actually played out in the classroom. And since that time, we've done a variety of different work with a number of different partners. We're working with the Gulf of Maine Research Institute on their lab venture experience. This is a field trip experience that all the 5th and 6th graders in Maine go to. And then we're creating some follow-on curriculum and classroom learning experiences for them. We're doing this work with Zoom In, which I'm going to talk a little bit more about later. We have both earth science and life science modules, and then we're doing this work with urban mobility that I'm going to be covering today. And we're also doing some work with National Geographic, building lessons for their middle school teacher resource library. So turning our attention specifically to Zoom In, the initial Zoom In work was done by our Center for Children and Technology. This is a group within EDC. They're based in our New York office. And the initial work with the Zoom In platform was in history, and it was an attempt to find a way to support students interacting with historical artifacts, and those could be documents or paintings or drawings or cartoons, pieces of writing, and scaffolding the student's ability to actually can carry out an analysis of those artifacts and then writing about it. And the focus was really that latter piece. It was about how to not only build understanding, but how to get students effectively writing about what they were learning and what they were discovering. This work, there were a number of lessons that were built. I think they're up to like 16 different history lessons. It's been nationally tested, and it's been a really successful program that's reached a pretty mature stage. And so our question was, would it be possible to take that approach that was used in Zoom In history, but instead of working with historical documents, instead of working with historical artifacts, to replace that part of the experience with data, and specifically with a data view using CODAP, the Common Online Data Analysis Platform that our friends at Concord Consortium developed. And so that idea became an NSF-funded project called Zoom In, Learning Science with Data. And we were sort of in the early days of developing that. That included 3 different modules in biology, as well as 3 different modules in earth science. And we were approached by GM, General Motors, as part of their philanthropic giving program. And they were interested in developing some learning experiences around urban mobility, around this topic that they're very interested in. And we were kind of, we were meeting with them and showing them kind of what our portfolio looks like. And when we showed them Zoom In, they got very excited about this idea and thought, boy, this could be a really exciting opportunity if we can find a way of integrating, problems in urban mobility and studying problems in urban mobility with a scaffolded writing environment where students would conduct analyses and then be able to write about it. And so all of that led to the development of this Zoom In mobility module that we're going to be walking through. And so there's a link here. I had also put it in the chat window. And so I would invite you all at this point to go ahead and go to that site. So it's beta.zoomin-gm.bbox.ly, and that will take you to the GM to the Zoom In Mobility beta site. Let's see, pulling up my chat window here. Okay. Oh, good. So, yeah, Natalia just put up the link again so that it's right kind of on top in your chat window. Once you join in, you'll be presented with this kind of a window. And so you may have to actually sign up, and I apologize for that, but it's a quick, it's a very painless sign up. And so you just put in your name and email address, make up a password, and then the student access code that you will have to enter is this one, which says Orange Oren 442. So I'll give you a second to do that. Actually, I'm going to stop sharing just for a moment so I can see people. So Sherry and Sarah, and those of you without cameras, Davel and McPhillips J, and Peggy Ezrock, are you? Just let me know when you're kind of there with the login.
I've somehow lost track of the student number or code.
Oh, okay. It's if you look in the chat window, it's all one word. It's orange, capital Orin, O-R-I-N, and then the number 442. Here, I'll share my screen again just so that it's on top. That's this on the right here, Orange Orin 442. So I'm trying to think what screen that takes you to when you've done that. But the class, what you want to be doing, so we should see a class that says the Concord Data Science webinar. And then you can go from that. There are 2 lessons to choose from, one of which is evacuation, when urban mobility is a matter of life and death. And the other lesson is called What is the Role of Bicycle Sharing Systems in Urban Mobility? That's the one we're going to choose. So let me share my screen again, and we'll see if that's where everybody is. Your screen may not look like this because there are some other classes here that are accessible to me, but I think we should be seeing this kind of a screen. And if we click on what is the role of bicycle sharing systems in urban mobility, it should bring up a screen that looks like this, and it looks like we have a bunch of people in the class. Terrific. And in the upper left-hand corner, you'll see a red link that says go to this lesson, and that will take you here.
So I think I created a student account. Should I have created a teacher account?
No, a student account is perfect. Thanks, Dan.
Yeah, so I think the student view is a bit different. We just see the list of assigned.
Oh, I see. Okay, that makes sense. But did everybody land on a page that looks like this?
Yes.
Okay, great. Okay, excellent. It looks like I'm seeing nods. I'm feeling good. So what I would invite you to do is to go ahead and step through this lesson. And what I'm going to do is I'm going to give you some kind of orientation pointers, and then maybe we can work through this together. In the top left portion of the window, you should see a series of links that say overview, hook, background, data orientation, investigation, and writing task. This is our lesson arc for this Zoom In framework. And this is something that has been modified from what we were doing with Zoom In history, but it's very much that same kind of a structure. And so as you will see in the overview, it provides an introduction to the lesson, what it is all about, what are the key sort of overriding questions or objectives for this lesson, gives you a link to get started, which takes you through the next page, and these are sort of your wayfinding tools that will carry you through the entire lesson. But then you can also, down below that, you can see that there are actually links that you can use to jump ahead to any portion of the lesson. And so it's just a way of shortcutting, sort of like a table of contents. But if we click Get Started, that will take us into the hook. And the idea of the hook is simply to get students engaged in thinking about the subject matter at hand. And so in this case, we're talking about bicycle sharing programs in general, the fact that this is something that's a growing phenomenon around the world, and getting people thinking. So there's a think about it question here. You see the little light bulb icon. And we're asking students, can you think of reasons that would promote bicycle usage in the city? And so, we're hoping to engage students just in some, sharing some thoughts about why they think bicycle sharing programs might be useful. And you can feel free to write in there. You don't have to. There will be points later as we get into this experience where actually filling out the boxes is going to be very helpful. So if we click Next, now we've moved past the hook into the background section. You'll see that there are a series of 5 pages in the background section. And this is really where we get into the meat of the content of the lesson, talking about what urban mobility is. So down in the 3rd paragraph there, you actually see, you see the definition of urban mobility in the 1st paragraph, and then talking about kind of the role that urban mobility planning plays in cities. So this lesson focuses on New York City. And so again, we're inviting students to think about, specifically in New York City, how might a bicycle sharing plan help, in New York or in other big cities? What are special about big cities that make bicycle sharing useful there? There's some detailed history of bike sharing programs worldwide. And then this actually turns out to be sort of an important piece of this whole thing, is recognizing that especially in an urban setting, any given transportation system is part of a whole network of transportation systems. And so thinking about bike share programs in the context of sort of the broader challenge of getting from point A to point B. And so that's something that the students will have to keep in mind as they're sort of sense making around the data sets that they're presented with. So we're inviting them to share their thoughts about what they interpret this graphic to mean. Some background information about New York City, since that's where we're going to be working in this particular exercise. You know, the fact that there are these 5 big boroughs and then all of these specific communities. And one of the things that we'll be using actually is we're going to be using the public use microdata areas, or PUMA data. And so these are records that come out of I believe they come out of the Census Bureau. And they're these smaller chunks of area that have roughly the same number of people in them. But we can get information about, you know, basic demographic kind of information about income and the number of cars that they use and how long it takes them to get to work, and what their income is, and just all those kinds of things. So with that background, we jump into our data orientation. And so you'll notice a couple things. One is that the data orientation is really about 2 things. One, it's about familiarizing the user with the data set that's in front of them. And it's also, in this case, it is about us bringing them up to speed on how to use the specific tools here. So for those people who haven't used CODAP before, and I'm curious actually, I'm going to stop sharing for a second. So how many people on this call have used CODAP before? Or maybe a more appropriate question is there anybody on the call who has not used CODAP before? Looks like I'm seeing smiles, which I assume means that people have used CODAP before. Yeah, Dan and John are both like, yeah, a little. Okay, that's great. I'm gonna take a detour here for just a second too, because one of the things that I had done in preparing for this is I had set up some Padlets. This is a new tool for me, and my friend Erin, who did this, she had used Padlet. And so what I would welcome, so Sherry asked a question, what grade level is this lesson designed for? It's designed for high school students. And one of the things that we found so far in trying to find teachers who are willing to pilot this is that urban mobility is one of those things that everybody seems interested in, but nobody really teaches it, or very few people teach it. So we found that there are teachers who teach things like, there's a teacher who teaches a class in urban ecology who is really excited about this. You know, this is something that's directly relevant. You know, we talked to some teachers in Detroit who are teaching just sort of general, you know, general science classes, and found this really interesting because it allows them to tie together concepts from mathematics and science. But because it's not like there's a course that's called urban mobility, you know, it was hard to get traction with those teachers. So we've expanded our testing to undergraduate classrooms as well, because in, you know, civil engineering classes and so on, you know, there are certainly going to be whole units taught on urban mobility. So we're kind of bridging that, you know, high school even to undergraduate. And so the Padlet that I set up here, and let me, I'm going to put the link in the chat window again. I would invite you to join in here. And what I'm looking for, because this is something that is really brand new, is just, I've kind of divided it into different things. So instructional design is just sort of the way that the lesson is laid out. I'm inviting you to share your thoughts on any of this stuff. So instructional design, interaction, user experience, user interface, things. Like one of the things that we know is it has been a challenge since day one is that the CODAP window is a bit restrictive. And, you know, but if you have other thoughts or observations to share, please do. Thoughts specifically about the data analysis, the data moves that we're asking students to do, the writing prompts, and that process of scaffolding the writing, or anything else that you want to share. So please feel free to comment in the Padlet, and we'll be looking over that, Joanna and myself, as we continue, you know, developing and refining this lesson. Ideas, thoughts, suggestions, complaints, you know, things you're excited about, whatever, please share those with us. All of it will be helpful. Okay, so back to the lesson. I just realized that I wasn't sharing my screen. I was talking about this Padlet that I was looking at and not sharing my screen. This is what the Padlet looks like if you're not already there. So in each one of these instructional design interactions, so on, if you just click on it, you can jot something down under that heading, and it'll get captured. Sorry.
Do we have to log in, Randy, to be able to do that? Because I don't have the pluses.
Oh, let's see. I haven't used Padlet before. If somebody there has a, allow viewers to comment on posts. All right, I'm just going to turn everything on. Let's see if that works. You may have to refresh your view, reload the page.
No, I still don't have the pluses.
Darn it. Oh, here we go. Those with access can write. Let's see if that does it. Sorry about this.
Yeah, you have to reload the Padlet page, but that doesn't.
That does it? Okay, great. Thanks, Dan. Bill, is that working for you now too?
I haven't gotten back to the page.
Okay.
Yes, it works.
Excellent. All right. Thanks for your patience, everybody. Sorry about that. Okay. So if we are in the data orientation screen, you know, one of the first things that we want to do is to orient students to the fact that you can look at the same data in multiple different ways. So, for example, we have this this median age column, and if we drag that to the x-axis in the graph view, we get a dot plot that shows the distribution of median ages. But we can also drop that onto the map, and we can see, you know, in these different pumas, you know, these different areas, kind of what the age range is. And I'm sure that those of you who have used CODAP know all this, but I think one of the most exciting things about it, you know, is this idea that once you've done something like this, you can, you know, click on parts of the map, and that will also be highlighted in the graph, and it will also be highlighted in the table. So there's this wonderful interactivity, interoperability between the different representations of the data. And so we're asking students, once they've done that, to just do some writing about what do the representations show. And one of the neat things that's built into the Zoom In framework is that we have these hint boxes. And so if somebody is struggling to understand what we're talking about, we have these little show me things, which launches an animated GIF and actually illustrates exactly what it looks like when somebody grabs that variable and drags it to the graph and to the map. So they have this sort of, very engaging little help tool to help facilitate that. We also illustrate the interactivity. So if you click on a dot on the graph, we can see that it has an impact on both the map and on the table. And then finally, we ask the students to think about what they're getting out of each of those different representations and what they're good for. So if we click next, so we can now, this is just a continuation of what we were just doing, looking at some other pieces of the data representation, dragging some different variables into the graph and into the map. And so, just experimenting with that, making some observations. This provides an overview of specifically what each of those attributes are. So in the table, these are the column headings on the table, and then this is the description of what each of those means. And so here we get into a little bit more detail about how to use dot plots. So in this case, we're bringing average household size. We're going to bring it down to the x-axis. And then we can display a mean for that. And so when we're asked what's the average number of people per household in New York City, we can display that. We talk about what each of the cases represents, what each of the dots represents in the graph, and then we also introduce the use of the case card. And I know that the case card is a relatively recent addition, at least in my experience with CODAP, and so when you select a particular dot, if you haven't used this before, it's kind of a neat tool. If you select a particular case, it allows you to see all of the data associated with that particular case in one place, rather than having to scan along the table to see all the data for that particular case.
Wow.
Really cool, huh, Bill?
Yeah, I just tried dragging Burrow to the y-axis, and that produced a wow from me.
Oh, cool. Let's try that. So we had average household size, and then we drag Burrow to the y-axis.
And I put the median on there too. And my wow was, oh, Manhattan really is different.
Yeah. My son, who's a freshman in high school, is just going through and learning all about means and medians and modes and standard deviations and interquartile ranges, and so this is very top of mind. He's taking a test on it today. I was coaching him one time. And so in the next data orientation piece, we start getting into correlations and this idea of, okay, so we're going to put median age on the x-axis and the percentage of people that don't have any vehicles on the y-axis, and then using a least squares line, to get a sense of what the correlation is between those variables, and then asking the students to think about, what does that mean? You know, how do you interpret that? And then getting into a conversation about the R-squared value and what the R-squared value means. And then finally, you know,
Randy?
There's a really interesting graph with income and no vehicles.
Can I say something?
please.
Yeah, in the first page, and the one that you were looking, we're first asking the students to actually, before they do the least square line, to look at the graph and have a sense of how the dots are, for them to first describe it on their own words, and then go to the next, just actually go and do the measurement. So, so we're not presenting them with statistic lines straight. First, we want them to think about the data. What do they mean? What they are seeing themselves.
Right. Yeah, that's a great point. So as you can see, what we're trying to do in all of this, in this data orientation piece of it, is to show the students some basic kind of data moves that they can do with the data and with the tools that we've given them to start making meaning from the data. And this is obviously setting them up to do an investigation where we're going to be, you know, asking some maybe more complex kinds of questions, you know, and ultimately thinking about, okay, if you were gonna add a bunch of bike share stations, where would you put them and why? So we're sort of building to this much more applied way of thinking about the data and kinds of applied analyses that we want them to be carrying out. And so Dan had suggested that we look at income.
You put income on the X and leave no vehicle.
Now that's interesting, isn't it? So I mean, the least squares line is actually sort of misleading there. So we have this one mass of data where as income goes up, the number of vehicles goes down, but then there's this cluster of points, you know, sort of out here in the in the Northeast.
Right.
You have
It's not number of vehicles that goes down. It's,
yeah, right. It's the percentage of people with no vehicles. So the more money people have in this cluster, the more money people have, the more of them actually have vehicles, the greater their percentage of households with vehicles.
But if you're really rich.
But the really rich people don't have vehicles.
No, because they all live in Manhattan.
Exactly. That's what it would be really interesting to grab the map and then highlight this group of points and see where all those people are located.
Or just drag Borough into the middle there.
Huh.
Manhattan and Brooklyn. Yeah.
Look at that.
Yeah, that's really interesting. So it's interesting that in Manhattan, you have the very wealthy and the not so wealthy.
Yes.
And there's this gap in between them. Fascinating.
So now that we are exploring different things, I mean, the data is so rich. You can go to a lot of different places. I mean, the students can just branch, but we have to focus and try to have an arc, as we said, and we are focusing on connectivity and where the bike shares are going to last. But you can see it's very rich. You can go anywhere. The teacher can have, you know, a lot of room to go any direction. So that's very cool, I think.
Yeah. Yeah, I think that, you know, this is one of the things that I would love to hear your thoughts on. And I think at the end of this, I would love to spend some time just having a conversation about this. But one of the beauties, I think, of this zoom in framework is that it allows you to create this very linear, very sort of scaffolded, directional introduction to the data, but it doesn't lend itself to what I would think of as really authentic inquiry, where you have students doing stuff driven primarily by their own curiosity rather than being driven by a set of instructions telling them what to do. And so the thing that I'm interested in is sort of how do you support that transition? You have a tool that lends itself really well to sort of very linear, very sort of circumscribed exploration. How do you transition then to a much more kind of open-ended framework? What are the best practices for doing that? Okay, so that's scatter plots, and then we get into our investigation, and so the investigation now, we're providing some background again about New York City, and thinking about these things to keep in mind. But then we're going to go and we're going to start really, digging into this exploration of New York City and some of these data that we have. So we're going to grab total population and we're going to put it on the y-axis, and we're going to grab employment and we're going to put it on the x-axis. And then we're going to grab borough, and we're going to take that to the center of the map. So we see the big boroughs here. Okay, and if we select, as we've done before, if we select a particular neighborhood, what we see is that the neighborhood is highlighted here on the map. We will also see that the neighborhood is highlighted in the table. And because we've just highlighted one, we can also go to the case card and we can see all there is to know about Bensonhurst and Bath Beach, which happens to be the name of that particular neighborhood. So what Joanna has us do in this next step of our investigation is to identify 3 neighborhoods where we have high percent of employment and a large population. So one way to do that is by grabbing all 3 of them, or you can grab them one at a time. And then we can use the case card again to show us some information about that. And then we're going to list those out. We're going to add those in here. And the reason that we enter them here, that I mentioned earlier, that there are actually places where it's helpful to enter things. One of the things that we can do in the zoom in framework is that if we fill in information here on the page, it'll actually populate a table later. So we're going to take advantage of that. And so in this case, this neighborhood is Flushing. We have a second neighborhood here, which is the Upper East Side. And third one here. This is the Upper West Side.
There is some choice in there because so many people will not pick up, for example, the last one because the population is slow. They might say, no, maybe I will choose that one.
Yeah.
So a little bit of room that not everybody is going to end up with the same neighborhoods.
Yeah, absolutely. And then the other thing that that we were asked to do then is to think about what are the two main methods of transportation that were used to move about in these neighborhoods. And you know, there are a couple ways of answering that. So we could look at them one at a time and say, okay, it looks like in this one we have transit is 37%. It looks like walking is 9.4%. The question that sticks out to me is, are the rest of them moving if they're not using transit and they're not walking? We can look at each of them in turn, or we can highlight all three of them, and in the case table it'll actually give us ranges. So you know, we can see that transit, that for the majority of these people they're using transit or they're walking. And so, Joanna, I was curious when I was going through this. So it says, which of these neighborhoods would you describe as compact or congested, and which ones as dispersed? How do you, what is the evidence that a student would use to make that assessment?
Well, the compactness could be, I mean, if they are, for example, walking, that means that places are close together. So
I
they
see.
can go to places. There is no hard data, but that's an inference that you can make, that they are in Manhattan, for example, it's all compact, so you can walk to places. You can use mass transit. Car is not necessary to go to place to place. That's one way that they can write. And the reason I'm asking them to write next to the the last question is asking them to figure out whether they are complex or dispersed, and actually write in the boxes, because that is going to populate a table, and the questions on the table, I don't want them to get back to this page. They will have their, for example, flashing is compact or is dispersed, in order to choose later on what neighborhoods they think the bike shares docks have to be put.
Got it. Okay, that makes sense to me. So okay, so in Flushing, it looks like we have 9.4% of people that walk. So that must be pretty compact. The Upper East Side. Wow, almost 20% of people walk. So that must be really compact. And the Upper West Side.
Yeah, that's
11.4. Okay.
Wow, I really find already there are so many variables that I have to keep thinking, okay, what does this mean? It's complex.
Yeah, and I have to admit, I think you know, Joanna has done just a terrific job of pulling this together, and I think this is the really hard part of this whole thing is finding those ways where you're giving the student a path through it so that they're not getting off in the weeds, but that it still sort of gives a glimpse into some of that richness, you know, that lies along the path.
one thing is that in the introduction we're talking about that thing, the idea of compactness, of that bike shares that have established in Europe first, has been done where there are colleges and cities, so people can go to places just jumping back, and that's the idea of having in the city. So in the introduction, if they will remember that idea of what is compactness, then they can use it here. So I suppose in the teacher guide, when you get at this point, you will have to tell them that they had to highlight that idea or go back to the background and read that area, that panel. You know?
And that's a really good reminder, Joanna, that I should have mentioned, is that we're developing a teacher guide to go along with each one of these lessons, so that the teacher isn't relying on, sort of doing what I'm doing of just following the directions and driving the students through it, that there will actually be a teacher guide, which gives them some mileposts and some direction about how to facilitate it.
I mean, on one hand, we have these data sets that are really rich, but you cannot have the students just play with it because they would be lost in what are they going to look at. So we have to have some direction. But then even if you gave them directions, there is enough for them to explore a bit. For example, in this example, not everybody is going to pick the ones Randy has picked. And so there is a little bit of play, and as we go along, there is going to be a lot more because these are using two variables, and we're going to use two different variables, and they're going to put it together. So it's going to get complex, but then you have to give them directions because otherwise the students will go everywhere.
Yeah.
So I was thinking about your question about how do you best scaffold the data exploration, but also give students choice and some autonomy and agency in their inquiry. And I noticed that there were something like 18 attributes initially in one of the exercises, and maybe reducing that set at the very beginning and let them play in a little pond. So maybe they play with maybe 3 to 4 attributes, but then one is the other one that they get to make a decision on. Mm-hmm. And it could be something that we don't even have in the data set yet, but really kind of narrowing their scope even more so, and then widening it. Because I think right now it's very scaffolded, but there's a lot of richness in here, but almost like it's really someone who has used CodeApp is like, wow, there's a lot going on here in the data set that I'm just a little like, wow, there's almost like, maybe I should just pick one bureau and look at that, or maybe I should just look at one, just a handful of attributes. Because I know that is it on orientation page, you have like list 18 of them, which is like, I kind of want to spend an hour just looking at why did you decide to pick those? And so kind of giving them just a little guarded view of the garden before letting them into the jungle.
As we go along and at the end of the lesson, actually, one of the questions says, since they have examined 6 of these variables, which is the best ones that you will use to decide where the camera traps were. So they will have a choice of which ones is the best they think and which bureaus they think and why. But that will be after they have looked at the data. Even though it's a little bit restricted, as you said, they will have the freedom after they have to look at it. So.
Yeah, I think this is very exciting, especially if you are in New York City and you're doing with multiple classes across the city, and each person wants to explore their neighborhood and then do a comparison with someone else in a different neighborhood.
Yeah, the amazing thing too is, and I'm sure that some of you, may know this, but this Puma data is available pretty broadly. I mean, because it's part of the census, you can get this kind of data for lots of different places. And so, one could imagine that after having gone through something like this, it might be possible for an enterprising teacher or student, to create a project where they would start with another data set from another city, from Detroit or from Boston or wherever they happen to be, and, sort of play out, explore it in some of the same kinds of ways. I would love to see something like that happen.
Can you talk?
I think, Sherry, to get back to your original suggestion, I mean, I think that idea of really limiting the initial exposure to a very small number of sort of variables and playing that out then adding to that is a really nice way maybe of helping, you know, facilitate that transition from something that's a very, you know, very prescribed, very directive kind of a process to something that is much more kind of open-ended and, you know, facilitating inquiry. Somebody else was going to say something and I talked over the top of them.
I was going to ask Johanna, how did you decide which attributes to include in this data set?
Mainly from the literature. I mean, because these bike sharing systems have been done a lot in Europe and also in Chicago and in San Antonio in Texas and Indonesia, other places. So just reading the literature and what they have used to study that, that's what I have picked up by following that.
It makes sense.
One of the things I love about working with Johanna is whether we're talking about bike sharing or we're talking about hairs that change color in the winter, or we're talking about, you know, whatever it is, the first thing Johanna does is become an expert and put together a library of just amazing papers about this. And that's the way she approaches every one of these things. And it's, we all learn so much from working with her. It's really a treat. Okay, so we have gone through and we've looked at where we see high percentage of employment. So we have people that are working in very large populations. And it looks like all three of these areas are relatively compact. Just as a reminder, so so that's where the Upper West Side is. This is the Upper East Side. And then this is Flushing. And so in all of these cases, it looks like there's a pretty significant portion of people who can actually walk, potentially walk to work. I'm just curious to do this. So you can see that it's not isolated to here. There are people in other parts of the city that also walk to work, even places that are less densely populated. But that gives us
one of the problems we do a lot of like scatter plots is that there is not one center. Manhattan is the big center, but then Queens have its own center. So there are actually one big center and different satellites, and that's something that is usually happening in other cities. So that's why the scatter plot sometimes is not, it doesn't have a high R. Yeah.
Mm-hmm. So let me, let's see, before we move on, so as we go through this, what we're doing is we're going to be sort of building the students' understanding of, you know, the way that people are moving around in different parts of the city so that we can get at the place where they're going to start looking at bike sharing and where that's a viable option and a relevant option. And I am more than happy to step through this with you and have conversations along the way if that's helpful. If it's feeling like, you know, I'd rather just sort of do this on my own later and maybe we can talk about other things, I'm happy to do that too. So, you know, Sherry and Sarah, I'm really interested in knowing, and other people who I realize may not be on camera, you know, I'd like to hear from you. What's most interesting and useful to you? I want this to be, you know, to be a good use of your time. Thoughts?
I guess I'm curious about sort of what were your most significant challenges in thinking about both the design of, you know, what you've presented here, the curricular design, and or maybe even the tool, and what you've seen in the classroom where students have challenges.
Yeah, those are all great questions, and and I think that we can talk about all these things, and I'll be anxious. It looks like Joanna had to step away for a second, but I'd be interested to hear her thoughts as well. I think that one of the first challenges that we've had in developing this is just that every time that you go to have the students make a move, make some kind of a data move, you realize that just the scaffolding around that, as far as the intellectual scaffolding of why would you make that move, and then the sort of nuts and bolts scaffolding of how do you do that, and supporting, providing enough instructions so they understand what they're being asked to do and how to do it. It can lead to a volume of material that can rapidly just be overwhelmingly large. And so the development process, and I would say this is true in our Zoom in Science work as well, is we sort of, there's a conceptual design of the lesson that gets big, and then you start adding detail and it gets overwhelmingly large, and then you start paring back and you start saying, what are those things that are really on that sort of linear arc that we want the student to go through, and what are the things we can pare away to get there? So from an instructional design standpoint, I would say that has been the biggest challenge. In terms of the user interface, to me, the biggest challenge has been that if you want to provide enough room, here I can go back and share my screen again just so that you can see what I'm talking about. Trying to find the right balance between this left-hand instructional area where we're both giving instructions and we're capturing student work and student thinking, but balancing the needs of that area with the needs of the window through which you're doing the data interaction has been really challenging, because you always want this to be as big as it can be, so you have room to spread out that table and to expand the map and everything else. And I think if there's something I would change about it in its current form, it's that we have this sort of hard bottom on it. Given that we can scroll the page, at the very least, my temptation would be to make it so that this window can get longer, so you can push stuff down if you need to, just to make room to see everything. And then a more elaborate solution would be to make it, sort of a floating palette, so that you could, when you come to do something here, if you click on it, it might take over the screen and you can do your thing, and then, click a little minimize and pull it back down, and be able to go back and forth with it. But from a user interface standpoint, I think that's been a big challenge.
This lesson hasn't been tried in classrooms yet, is that correct?
No, that was the third piece. Yeah, so I was supposed to be working with a group of students last week in Detroit on this, which is part of the reason that I thought it would be good for this webinar, because I would have just presented it. But then they canceled that workshop, or postponed it until May. So right now we are just recruiting to get some teachers to actually be piloting this in their classrooms. So we do not have any classroom testing yet on either this or the other lesson, the other urban mobility lesson, which is about evacuation.
And what topic and subject and grade are you thinking of recruiting?
That's a great question. At this point, the teachers that we've been working with so far, I've done a couple of workshops in Detroit, and we've gotten teachers. It's been a real interesting kind of mixed bag of teachers that have been interested in working with this. We have some teachers that teach various kinds of engineering classes and design classes that have been interested. I have a geography teacher who's interested, but it's been kind of soup to nuts. It's not like, it seems to fall in this sort of interstitial space where, it's not like, well, I'm a teacher who is teaching, AP biology, and I would like to use this lesson. It's, it's teachers that I think sort of have a personal connection to it and feel like their students might have a personal connection to it. But it's been a really diverse group so far that have shown an interest. And so I'm thinking that in terms of how we go about recruiting teachers, I think the idea is to just sort of cast a large net and hope that we find some people who, you know, for whom it's going to resonate with the kind of things that they're interested in teaching.
Very cool.
Did that answer your question, Dan? Were there other things?
Yeah.
Okay.
I like the arc of the inquiry task that you have. When you start with the overview, you have a hook, you know, and it leads to some action at the end, which is a writing task, but it also could be taking action in your community with that data. And as you were presenting this problem, and I was thinking of urban mobility more generally, I keep seeing these scooters everywhere.
Yeah.
Right. And so you have the fixed location of parking a bicycle versus the mobility where you can just leave these things somewhere else. And it adds an interesting kind of problem to say you can start investigating in this and then say, okay, it's like a transfer problem. And then now that you have this new problem where you have this other kind of data, so I could see, you know, this is a stepping stone towards doing another inquiry activity. I'm also wondering that I know that when we worked with high school biology teachers, having them collect their data for these growth chambers and looking at that data, that a popular part of the teacher workshop was having them do some activities that were just CODAP oriented. So it wasn't CODAP within the context of an inquiry activity, which they had to focus on that and the content piece and the practices. But they could just say, okay, in this particular period, we're just going to learn how to become a CODAP super user. So they weren't as worried about coming up and interpreting the data, but it was really around kind of getting fluency with the data moves to say, oh, I know how to slice and get the mean of this without reading too much of, like, you know, how is this different than this mean? But doing that. And so I imagine that you're probably, and I'm wondering, because it's also a tension in the classroom between teachers that need to, you know, have enough time in the classroom for deep, rich inquiry like this, and also saying, hey, guess what? You're going to spend a half of your period actually getting people up to speed on CODAP, but it seems like that would be a worthwhile investment. So I didn't know if this was like a series of activities that had CODAP, or if this is the first one in which case they might need a little baby step to learn just the data analysis by itself.
Yeah, you know, Sherry, it's interesting that you'd say that, because we're, you know, in this one, we're using CODAP. In the Zoom into Science lessons, we're using CODAP. In the work that we're doing with GMR, with the Gulf of Maine Research Institute, we're using CODAP. And so we're coming up against this in all these different settings with all these different teachers. And the suggestion that you just made, I think, is exactly the way that we've started thinking about it, that one of the things that we need to do is just to provide some really basic training in CODAP. You know, and I know at the Gulf of Maine Research Institute, there's another program that they run there called Vital Signs, and where they make extensive use of CODAP. And so they're using these, what do they call them? Bill, help me out here. Are they like challenge cards? Something like, oh, okay. I guess that they came up with this set of like simple data tasks. And so these are not couched in a bigger, much more complex lesson. It's, you know, it's really simple sort of data moves that you can do in CODAP, and just, they're fun and they're quick, but it gives you ways of sort of building people's facility at using CODAP, and using that as a way of sort of getting people engaged in the tool before you throw them into the deep end with one of these really involved, you know, kind of multi-step analytical processes. But I think you're right on that you know, that just helping teachers come up to speed and get really comfortable with CODAP, you know, it's something that you can do quickly, and getting them over that hurdle will make something like this much more accessible to them, and I think much less overwhelming.
I mean, with that said, there are resources on the codeapp.concord.org site
Yep.
for teachers who are just first encountering CodeApp to go there and get these lessons as well.
Absolutely. Yeah.
I wanted to bring up another aspect of developing curriculum that make use of data. So these data are from some year, right? And how do you think about the longevity of the lesson as time progresses? Because I know you have some actual bike stations that show up in the map. And by the time this gets in the classroom, there are going to be more of those bike stations.
Sure.
Is that a problem at all, or do you have a way of thinking about that? Because it has confronted people trying to design data-driven lessons since the beginning.
Yeah, you know, it's funny because the question reminds me of what we encountered with ocean tracks, which is, you know, the first reaction is, wow, this is really cool. You know, we're getting to work with tracks from white sharks and tunas and, you know, elephant seals and all this stuff. And that's really neat. And then the next question is, can we get real-time data? You know, just there's this immediate, you know, that immediate jump. And I think that it speaks to people's expectations about the fact that not only are data, you know, readily available, but they are readily available right now. And so you know, I think that it's one of those things where it's almost a marketing challenge, because the advantage with working with a curated data set is that you know what's there. And so when you're driving people through sort of a linear process, you know what they're going to see. But once you start, you know, adding like, you know, you start adding real-time data, you start adding that sort of potential for chaos into it, where the data move that used to show you this really nice correlation that you could then use to do something else with, all of a sudden the correlation completely falls apart because something changed. And so, you know, I think that working with a curated data set to teach the basic moves works really well and has some real advantages, but you have to frame it in such a way that people aren't feeling frustrated that the data are potentially historical data rather than being something that's, you know, that's really up to the minute and current. And, you know, and I think in a perfect world, you would use that initial training as an entree to, and here you go, here's how you get to the current, you know, brand new stuff, you know, and now you know enough to be dangerous when you go in there and start playing with that. But, you know, sort of framing it that way, because I think the challenges of working with real-time data, you know, or data that are constantly being updated, you know, it requires sort of a different skill set and a different sort of facilitation.
But I like that idea of starting with curated data and then where it's possible, pointing them in the direction of working with current data.
Yeah, absolutely.
Do you want to show the portion of it where you can actually see the bike stations?
Sure.
That will be in looking at the New York, examining what the New York area has already. I think it's number 5. Let's see, 8 or go to 8. I think it's probably in 8. No, 9. Right.
Okay. So it's
How to turn the bike docks off and on. Or
yes.
on.
Yeah. So let's see. So
So
where
I,
is that, Joanna? It's funny. I was playing with this right before I got on this morning.
So yeah, just click on the map and the instructions are there. Drag borrow to the center of the left-hand map identified. Then you can turn on and off the bike dock location by going to the layers. You go to the layers. Yeah, and then you click on bike stations. That's it. And but I put it at color because if you put borrow, if you drag borrow to the center of the map, so then you can see clearly. Yeah.
Oh, I see. Okay.
There are some in New Jersey.
want to color this in a way that's a bit more.
Yeah, something. Yeah, you can change the color. Okay, that's a good color. I think.
Yeah, I noticed, Randy, you make the map there. Yes. Excellent.
Yeah, so this is one of the things that has been added into CodeApp as we've been working through these lessons is this ability to put in multiple different data sets that both show up in the map. And if you combine them in the right way, it's actually possible to set it up so that if you click on a particular boundary, you will also select all of the points that are within that boundary if you combine them into the same table, which we didn't do for this. It wasn't necessary, but it is possible to do that if that's something that would be helpful in your own lesson development.
So I guess we're seeing the decision that the city bike people decided about where to put bike docks.
Yeah, and it's really interesting because there was a gentleman named Michael Wilkinson who did some of the first work when we first got this data set, and he was experimenting with it and had some ideas about how to develop the lesson around it. And he kind of took it in a really interesting direction with his class about sort of the equity issue of, is the way that these bike stations are distributed, is it fair? Which was a really interesting thing. And Joanna took it in a very different direction, with looking at different kinds of questions that focused more on sort of how does the bike share program fit into the overall strategy for moving people through the city, which was more consistent with kind of the learning objectives that we had set up for it. But yeah, you can take this in a lot of different directions. And one of the things that's clear is that, these bike share stations are very, very clustered in a relatively small area of the city and aren't really designed to serve, any of the outlying neighborhoods. And so the question that we start getting into in the lesson, and Joanna, I'd love to have you speak in more detail about this, is, if you were going to add some bike share stations or if you were going to change this layout sort of based on the data that we have, where would you put them?
So in this part is like I'm asking them to look at what the city has done, and with all the things, the investigations they have done, where will they extend it? Because one of the focuses in connectivity, and in one of the earlier investigations, they have the map of the subway. So the subway map gets to Queens, to other parts. So one idea that I was hoping the students, I will hope the students say, okay, we can put bike docks in other parts that will connect with the subway to get into the city, to wherever they go. Because these bikes is probably serving tourists, a lot of them. And so, but now they will know better where would they put it, the bikes that are different. But in this particular part, they are just examining what the city has done. In the next section, they will have their input. And in the last section, they will say, okay, what am I going to use? What variables am I going to use to decide where to put it? And the questions are focused on think on connectivity. Think how can you help mobility, which is all about moving people in and out of places using transit and using bikes. And that's the final the writing piece where they have to, if we go to this writing piece, Randy? So in the writing piece, we're asking them first in urban mobility in New York City to actually think of what they have explored 4 different attributes. So I wanted to, in a small paragraph, tell them why we were using those attributes and what do they tell them about how people move in New York. In the second part, they had to think about the bicycle connectivity, which is probably one of the most central parts of the lesson. So given to where the dock stations are in New York City, where do you propose to put them so you can help with this connectivity, urban mobility, because that's what it means. And then in conclusion, do you think that bike sharing programs help urban mobility in a big city like New York City, and how will they help? So the main focus is first having them explore how people move, commuting time, how much they earn, to have an idea of what kind of people do, how do they move. Then we go into connectivity, in the sense that who uses transit, because most of them use transits. But then there are other things they do, like walking or car or bicycle. And so that will give them a sense which neighborhoods need bicycle shares. And what you were talking about, fairness, I mean, there are some poor neighborhoods, well, poorer, that have transit. They could use bicycle to go to the transit and then take transit to the city. And then in the city, take bicycles to move about. So that's what I'm hoping these students will, at the end, will write. So
I had a thought, and I've been having to walk in and out, so I hope I'm not duplicating something. But that is, I am wondering what it would be like to have students speculate on how those figures might change as a result of the changes they're proposing to bicycling. I know in my own life, once I bought a bicycle and I wasn't relied on public transportation, my work patterns changed. I could work much further away from home, for instance. And so I'm wondering, if students would be interested in speculating about effects on income, effects on distance to work, and changes to things like use of public transit, things like that.
That's a great idea. Yes.
Yeah, that's really interesting, Lynn. Just out of curiosity, where are you based?
Oh, right now I'm in Massachusetts, but at that point I was living in upstate New York in a place where the public transport, well, in Rochester, New York, and the public transportation really was, you had to make 2 connections to go anywhere.
Uh-huh.
And when I could bicycle, I could, once I worked up my stamina to being able to bicycle a half hour each way, 45 minutes each way, it vastly expanded my job possibilities.
That's amazing.
I mean, Boston is, I don't know where in Massachusetts it is, but Boston is a very compact city as well, the area where the universities are. So, if there are data about census, they can use that. But okay.
Excellent. No, I think that's a great suggestion, Lynn. I like that idea about, sort of taking that, and turning it around to sort of looking, forward looking about, okay, so if we were to do this, what would we expect to see? What might we predict? The other thing that I wanted to just point out quickly is when the student goes to do their writing task, one of the things that we're able to do when we're authoring a lesson is to identify those pieces of the student work that they've done through the course of the exercise that will show up in their notes. And so, so you can see, earlier on when we were talking and I was taking notes and saying, okay, where are those neighborhoods that have high employment and large population, and are they compact or dispersed? And, I made those notes. If we had gone through the whole thing and made those notes, this would all be filled in. So we can bring not only these tables, but we can select, if they've done some writing earlier, they've done some reflection earlier, they've annotated a map or a graph or whatever. All of that kind of material, we can tell the system to pull that over into their notes, so that when they go to do this culminative writing experience, they have access to some of the things that they've produced in the course of the exercise that they can then draw from when they go to do the writing at the end.
One thing I wanted to say is, someone was mentioned that maybe this would move the students to do something, so some activity, could write a letter to the council, whatever. There are caveats, and early introduction, I focus a little bit on that. For example, why people doesn't use bicycles, because there's no bike lanes, or because there is no this respect between cars and bicycles, or people are not used to bicycles. So that kind of mentality have to change, maybe with advertising or whatever. So that infrastructure is not there in some parts. So that's one thing that the students can have an input on that. So.
Other thoughts, questions, suggestions?
I'm thinking about how much students can learn with this activity as you've got it structured, and especially if there were time for them to do a project on their own, but that there's currently, not that I can think of anyway, no logical, natural place to put it in the curriculum. Mm-hmm. And what a shame that is.
Yeah, and it's one of those things where it was, this sounds like a cop-out, but it was, GM really specifically wanted us to develop some lessons around this, and whether it was actually going to get used in a classroom was kind of irrelevant. It's the topic that they wanted us to be working in. And I agree, it's one of the things that was that has been kind of an eye-opener to us, is just, it's like, okay, so we've developed, these really cool lessons. Who's going to use them? It's been really a much more challenging piece of this whole project than I ever expected it to be. Because we're so used to working in, biology or earth science, and and we know that territory really well. This was new for all of us, both just in terms of the topic, the subject matter. I've never taken a class in urban mobility. I didn't even know what it was.
Yeah. And maybe in college, someone who is interested in architecture, or maybe in high school, something like that. I don't know.
Yeah.
So it's an interesting debate. I mean, we've been going around on this even since the DSET conference a couple of years ago about, should data science and data practices be its own course? Should there be a data science literacy or data science something type focused course? I mean, it's not inconceivable to think that as this gets more important, that a course focused on it, like engineering courses, like tech ed courses, are ubiquitous now in schools, and those didn't exist 5 years ago or a little more than that. So there's a trend there, at least, and we'll see if it's a fad or a growing trend toward data and data analysis skills. It clearly does resonate with science classes in the sense of being able to analyze data, and a lot of some of these same moves you're using here would be used to analyze public science data sets.
Yeah.
But, you know, it's really hard to convince science teachers to give enough time over to the complex, you know, thinking that needs to go on in managing and exploring data.
One, sorry. One of the things that we're doing in Zoom in Science, we use data from professors, from people who are doing actually collecting data and using that. And one of the things of the new generation, the standards, is that students in science are supposed to think a little bit like scientists. So what we do, and we kind of weaved into the lessons, is the idea of how science works. Science work by looking at the data, making hypotheses. So we kind of try to get into the practices as well as the content, and as how do they use and manipulate the data with CODAP. Because that's one of the main areas that we need students to do, to think as a scientist when they do science.
It's true, but again, really challenging. We have another project called Inquiry Space that is really focused on students doing experiments and collecting data, students using simulations, all in the sort of disciplinary focus that is very familiar to the teachers. Like they're already doing motion or diffusion osmosis, or pick a topic that they're already doing in class, and we're saying, and you should add this layer of students understanding how to collect and analyze and communicate about data. And it seems like it should be a really great fit, but it's a struggle for them. They push back on saying, well, but that's going to take me twice as long to do that same topic as I normally would do without that focus. And so I see it as a real challenge for us who want to support students really diving into and working with data to find that place in the curriculum. And it may be that it has to, the primary place it's done is in a separate course, and it's expected that you draw upon those skills in all the science courses or economics courses or engineering design courses, where it should be integrated there. But no one wants to teach it from the beginning part because it takes too much of their course time to do it.
Yeah, but as you pointed out, we're in a time of transition with respect to use of data, and we don't know how it's going to turn out.
Yeah, we don't.
My own preference would be that we figure out how to integrate use of data, which means rewriting science curricula, or redoing it, so that we're not saying, yes, now you're going to take twice as long to teach this topic. This is the amount of time you're going to teach this topic. I had another thought too, which is our colleague Andy Rubin at Turk has a project called Data Clubs, and this material would be ideal for an after-school or a club to orient students towards a data set that they wouldn't otherwise meet. And then it's a club. So some of those students can go on and spend months with just urban mobility issues.
Yeah.
So what Bill had said, I think exploring the out of school realm is really important. I can see a lot of youth activism being taken up with this type of activity. And also, if you look at sort of alternative, educational programs, thinking of international baccalaureate programs when they have the creativity, action, and service requirements, that this could easily serve that purpose because it is crossing the 6 areas, and also because IB is international as well. That could be an interesting way to move it work.
So how do you get this material in front of them so that they can think about using it?
You would have a professional development day for IB coordinators, because there's one at every high school, and then create a write-up, and then you give them to them that they can then give them to their students to say this is an option. Because oftentimes they'll be looking for creative projects like I'm going to go help the Red Cross and design a solution, or I'm going to they're very creative projects and they're fairly open-ended, but it is a requirement So it is kind of tied to school.
I'm working with a small group that's developing a merit badge for the Boy Scouts in data science. This would be perfect for that.
Yeah.
That's one of the things you do to earn that badge.
That's great.
And I've been talking with a group that is wanting to do some kind of educational initiative around sustainability and resilience in communities. And, you know, our initial thoughts were, you know, this could be done in like as a library community activity, like intergenerational kind of thing with different people. Some people might be doing Sage Model or models of the system, and other people will be getting public data sets from the region and doing CODAP, you know, analysis, data analysis using CODAP. There could be people who want to do the storytelling or push the political activism to make changes based on what they're figuring out.
Yeah. And the important thing is that going through this module gives you a perspective and tools and a source of data that that you can take forward.
Excellent.
So backing up a little bit, for me, I keep running into this very basic cognitive issue with students and teachers in that it seems to be very easy for it to be a cognitive load to learn data science moves in the context of an unfamiliar phenomenon. But if they're not working with it in the context of a phenomenon, it just seems like moving stuff around. I mean, you need to have some kind of goal. And I don't know what grain size. I don't have an answer for what would be the best way to approach that. I just know that when the people who do find it easy to learn these data moves, I think are mentally mapping it to some kind of goal. They're able to do that, and not everybody finds it easy to do that.
Mm-hmm. Yeah, I think you know what you're touching on, Lynn, is so much at the heart of this. And I'll throw out there a thought that something that I've been thinking about recently is I think that the ability to sort of gracefully transition in and out of a mathematical frame of mind, the ability to take a real world question or problem and to be able to mathematize it and think about it in a quantitative way, and then to be able to move back out of that world and think about what its ramifications are in terms of the decision I'm going to make or the plan I'm going to put in place or whatever, that is a habit of mind that I think can be taught, but I think that it needs to be taught starting really early on. I don't think that if we wait until high school to start doing that's early enough. And I've been talking with a colleague of mine at EDC, whose name is Sarah Sword, who does a lot of early math intervention and work. And we've been talking about studying that very specific thing, about sort of how do you help build that facility, you know, that habit of mind that allows somebody to move gracefully in and out of that very quantitative frame, which I think is, and maybe I'm misunderstanding, but that's kind of what I think about when I hear you talking about those people who can easily, you know, think about data moves and understand what those data moves are. But I think the question you're asking is a question I'm really excited about.
Yeah, that's exactly what I was thinking. It was something I kept running into when I was tutoring adult math phobics.
Yeah, and it's, you know, that sort of, it is almost, I think that the way that we have taught mathematics as sort of this discrete discipline, and even though we always talk about the applications when you're in mathematics, there's, it always feels pretty siloed. And in other disciplines, when we're talking about things that are mathematical, we sort of teach them as if we can't assume any expertise in mathematics, The funniest example that I can think of is physics. I can remember, in physics that, in college, you either went to the physics that assumed you had calculus, or you went to the physics that assumed you didn't have calculus. And there were two different classes. And it's like, physics is calculus is physics. It's and why would you separate the two? But I think that, to me, that's sort of at the heart of what makes this idea of data literacy and data science something that is not synonymous with teaching every kid statistics. That's not what we're talking about. It's about teaching that ability to take a real world problem, a real world question, be able to articulate it in mathematical terms, to be able to use data and derive meaning from the data and apply that to that question. That's what I mean when I talk about data science and data literacy.
There's an interesting way of thinking about this activity, the urban mobility activity, as, okay, we've got this mass of data, but now let's make it into a model of what's going on.
Yeah.
So that we have a data model of New York and movement through New York, and a model that predicts, or we can use to recommend where additional bike sharing programs should be put. And that conversion of just data into a useful model is something I don't think we know very much about.
Yeah.
In terms of how we ourselves, let alone students, make that large move, if you will, to from data to a useful model. Which brings up the ever-present need for more research, data science education research, in how students approach data and how they learn to work with data. And it's very different than the statistics education research, which is not so much about data. It is, some of it is, and there's a lot of really good research in statistics that's applicable to this, but there's another whole realm in data science that we need to understand.
And the interesting thing is too that I think, especially based on, like Bill and I attended this meeting of the American Statistical Association, and the interesting thing is that they're asking themselves all these same questions. And in fact, the suggestion earlier about from Dan about should we have a sort of introduction to data science course? Is that something that we should be thinking about? The very same suggestion was coming out of the American Statistical Association, and the idea of a data for all course, that would accomplish exactly those same kinds of things. So I don't think that, that we are, that we're in conflict, with people who are more on the mathematical statistical side of the world. I think that we're all recognizing that this sort of more integrative, interdisciplinary endeavor about, taking real world problems, figuring out how to apply mathematics to them, using computers to help us with our visualizations and our analyses, which is another piece of this that we haven't really focused on. But all three of those things are sort of a piece when we talk about data science and about data science education.
That's beautiful, Randy. Thank you.
Should close with that.
Yeah.
Now we go ahead and wrap this up. Great. Well, let me go ahead and me go ahead and share my screen.
What a wonderful conversation.
Oh my goodness, thank you. What a wonderful conversation. Thank you, Randy, and thank you everybody for your participation. There was a lot of great engagement today, and I appreciate that. If we did not get to your question, or if you have any additional questions, you can either tweet to us or email us. We'll respond to you tomorrow or as soon as we can. We had a lot of great interaction, like I said, and I'm really grateful to all of you for making really rich discussion happen. Randy especially, wonderful, wonderful facilitation. I appreciate your time with us today. For those of you who are wondering, we will send you a link to the recorded session shortly. If you enjoyed this webinar and you'd like to attend future data science education webinars, our next webinar will be on April 3rd with Kim Castens, whose webinar topic is what kinds of questions do students generate as they view data visualizations. So that'll be a lot of fun. You can sign up for Kim's webinar and future webinars at concord.org/meetup. You can stay connected with us on Twitter at CodeAppDataSci. Use the hashtag DataSciEd to tweet us any additional questions or resources and we'll respond to you. Please feel free to visit our website at codeapp.concord.org to connect with us as well. And we look forward to seeing you next time. Thank you, everybody.
Thanks,
so
Randy.
much for taking the time. I really appreciate it.
We do too.
You do too.